we will be considering questions on linear programming problem minimization. A company purchasing scrap material has two types of scrap materials available. The first type has 30% of material X, 20% of material Y, and 50% of material Z by weight. The second type has 40% of material X, 10% of material Y, and 30% of material Z. The cost of the two scraps are Rx 120 and Rx 160 per kilogram respectively. The company requires at least 240 kg of material X, 100 kg of material Y, and 290 kg of material Z. Using graphical method to obtain the optimal quantities of the two scraps to be purchased so that the company requirement of the three materials satisfied at a minimum cost. So for us to use a graphical method to obtain the optimal quantity, we have to formulate the linear programming problem. So first step is to formulate the linear programming problem is to write down the decision variable, that is by writing down the decision variable problem. So decision variable. So we have to what? We have to donate remember that a company purchasing material has two types of scrap material. So we let X1 and X2 denote the two types of scrap material. Let X1 and X2 denote the two types of scrap material. That is, we have let S1 and S2 denote the two types of scrap material. The next step is to formulate the objective function. We formulate the objective function. And for what's formulation of objective function deals with minimization and maximization. That is an optimal solution. Remember that we are dealing with cost. We minimize cost. So our objective function will be on cost. So for us to formulate the objective function, so we have to check the cost of each material. So the cost on each material, because the materials are two scraps. So the cost of the two scraps are Rs 120. That is cost on first scrap. Cost on first scrap. Cost on first scraps is what? Is 120x1. 120x1. Cost on second scrap. Is 160. RS is a currency of a country. Is a currency. RS is a currency. Like Nigeria, we have naira. USA, we have dollars. RS is a currency. I could not remember the country that uses RX. So it's a currency. So it's 160. RS 160 S2. 160 S2. So this is the cost on what? This is the cost on what objective function. That is the cost on the first part is 120x1. The cost on the second part is 160x2. And the reason we're adding x1 to first part and s2 to second part is what? We represent as a decision variable that we should represent x1 and s2 denote the two types of scrap material. So our total cost will now be our total cost on the two types of scrap on the two types of scrap material So the total cost will now be 120x1 plus 160x2. So this is since we have gotten the objective. So remember, in objective function, since we are minimizing cost, since it is on cost, then we minimize. Remember, we are dealing with cost, so we minimize. That is, we minimize by let z should be what? 120x1 plus 160x2. That is, our z should be what? Let z is equal to 120x1. So therefore, we're going to have let z is 120x1. So I can say by we minimize the cost. That is minimize z, minimize z, 120 x1, then 160 x2. So then next is what? To formulate the other constraint, that is to formulate the constraint. So to formulate the constraint. So if you look about the constraint, we have on x, we have on y, we have on z. So on x we have what? The first type has 30% of matter, that is constraint on first types. Constraint on first types, that is on the first types of square, we have what? 30% on x1 and 30% on x1. Then the second one is what? And the second one is what? And the first type we have 30% on x1, and also we have on what? We have 20% of material y, 20% of material y, and our material y is what? On x1. So this is x1, we are still on x1. That is our first square beneath x1. Then and 50% of material z, that is what? Material z is what? Is still on first square. So we have what? 50% x1 as well. So on second type, so on second type, what do we have? We have the second type has 40% material, 40% material on x1. Then we have 40% 10% material of y, 10% material of y, which is what? S2. We are dealing with on second type, which is S2. So it is S2. And then on Z, what do we have on Z? 30% of material Z, 30% of material Z. So these are the what? These are the constraints. That is on type of what? Type of material of the scrap. First scribe is what? 30% on S1, 20% on S1, 50% on X1. That is on first scribe, we have on first type of scribe we have X, Y, and Z, and our first scribe has been denoted as what? X. So on our second type of the scribe has been denoted as what? S2, which is X, Y, and Z. So what are we going to do next is what? So what are we going to do next is what? To add the non-negligibility constraint. Non-negligible constraint. Since the word, if you look about this, it is what? Our coefficient of the decision variable is greater than or equal to 0. That is greater than 0. That is either greater than, that is they are greater than or equal to 0. So we are going to have x1, our first square, and our s2 is greater than or equal to 0. So remember, when we are formulating, we don't have to, it must not be in percentage. It means we have to convert this one to percentage. So our 30% is what? We are going to have what? Our 30%. So on our first type, we have 30%. So 30 divided by what? 100. So we have to convert it to what? Constraint will now be, our constraint on first type will now be 0.3. So let me minimize what? So I'm going to have what? So on the constraint, I'm going to have on the constraint, I'm going to have 0.3 x1, then plus. So I want to take, I'll now be considering first type x1 and what? Second type x2, that is x and x, which is what? X on x1 I have what? On second type of this is x, and x and x, which is the net x1 and x2. On the first type I have y, this is for y. On this one, on second type, this is for y. On z, this is for z. On this is for z. So I'm going to have 30 divided by what? 100, which is 0.3. So I'm going to take what? 40 as well. So 40 divided by 100, I'm going to have 0.4. 40 divided by 100, I'm going to have 0.4. So 0.4s2, 0.4s2. So on my y, this is my y, this for my y, this for my y, that is s1 and s2. So I'm going to have 20 divided by 100, 0.2. I'm going to have 0.2 x1 plus 50 divided on 10. 10 divided by 100. 10 divided by 100 is 0.1. So I'm going to have 0.1 s2. So on my z, that is on my xz, on my first type of z, on my second type of z, which is s1 and s2, 50, I have to convert 50% to what? 50%. So 50% is what? 50 divided by 100, which is what? 0.5. 0.5 x1 as well as 30 divided by what? 30 divided by 100, which is what? 0.3. 0.3 S2. So these are my constraints, and that is my x1, s2 is greater than or equal to 0. And these are my constraints and my non-negativity constraints. So since we are dealing with minimization and what, and we want to what, and since we are dealing with minimization and we want to convert it to what, since it's constraint, and if you do this question, we are having that the material, that is the company, require at least 240 kilogram of material X. So for material X we have 240 kilogram, and we are dealing with what? Minimization. It means our inequality sign is greater than or equal to what? 240 kilogram on Y. This is on Y, which is what? S1 and S2. What do we have? We have what? We have 100 kilogram of material Y, which is what? 100. Then as well as on Z, what do we have? 290 and 290 kilogram. So it means, and remember, we are dealing with minimization of cost, and we want to plot, we want to what? We want to use graphical method to solve this. So it must not be in what percent. Since we are dealing with what? We are dealing with cost, we have to multiply the constraints. Multiply all the constraints by what? By 10. So that what? So that all the percent, so that we are going to have what? So we are not going to have a decimal, we are going to have a number. That we are going to have a value in a whole number, because we want to plot what? We are minimizing the cost, and we want to represent the constraint, that we want to represent it on what? Graphical method. So we have to multiply by 10, since the constraint is minimization. So if we multiply our first constraint by 10, we are going to have 0.3 times 10. I'm going to have 3. So I'm going to have 3. So I'm going to have 3. I'm going to have 3x1 plus, if I multiply 0.4, if I multiply 0.4 by 10, I'm going to have 4. 4s2 is greater than or equal to. So I'm multiplying throughout by what? 240. So 10 will multiply 240. 240 multiplied by 10. I'm going to have 2,400. 2,400. I will do it from the what? Second constraint. If I multiply 0.2 by 10, I'm going to have what? I'm going to have 2. 2x1 plus, if I multiply 0.1 by 10, I'm going to have what? 1. That is S2 is greater than or equal to what? 100. So 100 multiplied by 10, 1000. That is 100 times 10, which is what? 1000. So I will go for my what? Last constraint. If I multiply 0.5 by what? 0.5 by what? By 10, I'm going to have 5. 5x1 plus, if I multiply 0.3 by 10, I'm going to have 3. I'm going to have 3s2 greater than or equal to 2900. So it means I've what? I've multiplied throughout, I've multiplied the constraint throughout by 10, since the constraint is minimization. So my mathematical formulation of the LPP. So my mathematical formulation of the LPP will now be on objective function. What do we have? 120x1 plus 160x2. We are minimizing. With this is minimization. 120x1 plus what? 160x2. Subject to the constraints. So what are the constraints? These are the constraints. 3x1 plus 4s2 greater than or equal to 2400. On my second constraint, I have 2x1 plus s2 greater than or equal to what? 1000. Then on my last constraint, I have 5x1 plus 3s2 greater than or equal to what? 2900. 2900 greater than or equal to 2900. Then these are my constraints, these are my function. Then to add my what? Non-negativity, that is non-negativity. So I'm going to have, since my decision variable is what? Is greater than or equal to what? 0. So I'm going to have x1, s2 is greater than or equal to what? 0. So I formulate the problem on I formulate the what? The linear programming problem. So my next step is what? To solve graphical method. You can make screenshots for this. So I want to solve graphical method. Since you have formulated the linear program problem, this is what you get, and I want to solve using graphical method. So in graphical method, remember that I told you in our previous lesson then that in graphical method, for us to what? For us to solve a linear programming problem, as if you have formulated it in graphical method, it means that what? It means we will let x1 to be 0 and x2 to be 0. That is, we equate x1 as 0 and s2 as 0. That if you equate s1 as 0, what are we going to have in first constraint? We equate s2 as 0. What are we going to have in second constraint as well? What are we, that's what this and when we are doing that, it means what? Since we are doing that, our inequality sign is going to change. So let's start from the first constraint. So we want to solve this graphical method. Before we can solve this, we have to get value for the constraint so that we're able to plot it on graph. So on 3x1, on the first constraint, we have 3x1 plus 4x2 greater than or equal to 0. So 3x1 plus 4x2 greater than or equal to what? 2400. This is the first constraint. Okay, if x1 is equal to what? When x1 is 0, when x1 is equal to 0, what are we going to have? So when x1 is equal to 0 on the first constraint, we are going to have, whenever you say x1, you put 0. 3 is equal to x1 plus 4x2. So this inequality sign is going to change equal to what? 2400. Since we solve graphical method, so if you multiply 3 by 3, you are going to have 0, which is what? 0 plus 4s2 is equal to what? 2400. So we are going to have 4s2 is equal to what? 2400. So if you divide both sides by 4, we are going to have 4 divided by 4 will cancel 4, then 2400 divided by 4, we are going to have 600. So we are going to have s2 is equal to what? 600. That is when x1 is 0, s2 is 600. When s1 is 0, s2 is 600. So we are going to test for the second one. This from the first constraint I said that when s2 is 0, what are we going to have for x1? When s2 is equal to 0, what are we going to have for x1? What are we going to have for x1? So these are the first constraint. This is the first constraint. So we are going to have 3x1. So 3x1 plus 4 at s2 is 0. I'm going to put 0 greater than or equal to. So greater than or equal to will turn to equality. Since what we are solving graphical method and we have equate s2 as s2 is equal to 0. Since we have equate s2 as 0, the inequality sign will change to equality. Then 2400. So if you multiply 3 by x1, I'm going to have 3x1 plus 4 multiplied by 0, I'm going to have 0. So we are going to have 3x1 is equal to what? 2400. So here we are going to have, we divide both sides by what? 3. So we are going to have 3x1 all over 3 is equal to what? 2400 all over what? 3. So 3 will cancel 3. So if you divide 2400 divided by 3, 2400 divided by 3, we are going to have 800. That is our x1 is what? Our x1 is what? 800. So it means when our s2 is 0, our s1 is 800. So we are going to have s1 is 800 and s2 is what? 0. So let's do this for second constraint. So let's do it for second constraint. Second constraint is 2x1 plus s2 is equal to what? 1000. 2x1 plus s2 is greater than or equal to what? 1000. So when x1 is 0, when x1 is equal to 0, what are we going to have? Since we are making s1 as 0, we are going to have 2. Whenever we see x1, we put 0. 0 plus s2. This inequality sign will change. Since we have what? We have equated that what? s1 is what? 0. Equal to what? 1000. So if you multiply this one by 2, we are going to have 0. So we are going to have 0 plus what? s2. So we are going to have s2 is equal to what? 1000. So when our x1 is 0, our s2 is what? 1000. So these are the coordinates. That is when s1 is 0, our s2 is what? These are the points. When s1 is 0, our s2 is what? 1000. So when s2 is what? When s2 is 0, what are we going to have? It means whenever we see s2, we put 0. We're going to have 2x1 plus s2 at 0 is greater than or equal to what? 1000. So we're going to what? We're going to have what? We're going to have 2x1 is equal to this. Remember, inequality sign will change to equality because what? We equate that s2 is what? 0. 2x1 is equal to what? 1000. So we're going to have 2x1 over 2 is equal to what? 1000 all over 2. So if we divide 1000 divided by 2, we're going to have 500. So we're going to s1 is equal to what? 500. That is when x1 is 500, our s2 is what? Is 0. So these are the coordinate points. Coordinate points. So our last constraint is what? 5x1 plus 3s2 is greater than or equal to 2900. When s1 is 0, when s1 is equal to 0, what do we have? We have 5 is equal to 0 plus 3s2 is equal to 2900. If you multiply 5 by 0, we're going to have 0. So we're going to have here, we're going to have 3s2 is equal to 2900. If you divide both sides by 3, we're going to have what? 2900 divided by 3. 2900 divided by 3. We're going to have 966.7. 966.666. So approximately to 4 decimal, approximately to what? To 1 decimal point or 4 significant figure. We have 966.7. That is our s2 is what? 966.7. So it means here, it means that what? When our x1 is 0, the coordinate point, our s2 is what? 966.7. So we are going to try for when our s2 is 0, what are we going to have for x1? So when s2 is 0, when s2 is equal to 0, if our s2 is equal to 0, what are we going to have for x1? So we just put s2 in this. So we are going to have what? 5x1 plus 3s2 at 0 is equal to what? 2900. So if you multiply 3 by 0, we're going to have 0. So I'm going to have 5x1. 5x1 is equal to what? 2900. I have to divide both sides by 5 so that I can get my value for x1. So if you divide 2900 by 5, we are going to have what? We are going to have 580. 580. So if you divide, so our x1 is what? Our x1 is what? 5 what? 580. Which means when my s1 is 580, as when my s1 is 580, my s2 is what? Is 0. So here I'm going to have, in my first constraint here, what do I have here? My first constraint here is what? My first constraint is when my first constraint is what? 0. My s is what? 600. That is on my first constraint, when my s1 is what? 0, my s2 is 600. When my s2, when my s2 is what? When my what? s2 is what? When my s1 is 0, when my s2 is 0, my s1 is what? 800. That is 800. On my second constraint, when my s1 is 0, I have what? 1000, which is this. And when my s2 is 0 here, what do I have? I have 500 on my x1. So on my last constraint, when my s2 is what? S1 is 0, I have what? 966.7. And when my s2 is 0, what did I have? I have what? 580. 580. So these are the coordinate points I'm going to locate on a point so that I can get my optimal quantity. So I have to locate this one on a point. And if I locate this one on a point, then I get my optimal quantity. It means I've solved Sarika method. Since I have formulated my problem, that is, I have formulated the linear programming problem, so I want to represent the constraint on graph, that is, using graphical method to solve it. So remember that this is our what? This is our coordinate points. On our first constraint, when x1 is 0, I have what? S2 at 600. When s1 is 800, our s2 is what? 0. On our second constraint, when s1 is on 0, my s2 is 1000. When my x1 is 500, my s2 is what? 0. And on my last constraint, when my x1 is what? 0, my s2 is 96.7. And when my s2 is what? 500, what do I have? I have what? When my s2 is 0, that is when my s2 is 0, my s1 is 500. So I want to locate the coordinate on graph. So if you look the coordinate point, The highest on x1, the highest on x1 is 800. The highest on s2 is what? 1000. So it means I can make my scale to be 2 centimeter represent 100 units on both axes. That is 2 centimeter 100 units. So my scale 2 centimeter represent 100 units, 100 units on both axes, on both axes. So this is my what? This is my S2 as a vertical and this is my X1. So since my S2 has highest of what? 1000. If I start from the origin from here, so I have from origin from here, my scale, that is from here to here is what? 100, 100. From 100 to here is 200, 300, 400, 500, 600, 700, 800, 900, 1000. So I can start from here, I can start from here. So let me start from here, from the origin. Let me start from here. So my vertical is my S2, my horizontal is what? My X1. So I want to draw the graph. So I have to what? Draw the horizontal line. So since I've drawn my horizontal line and my vertical line, so I can now locate my scale, that is 2 centimeter represent 100 units. It means here is what? 200, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. That is 1000. And from my what? Origin to my X1. This is my origin, my starting point. So here I'm going to have what? I'm going to have 100. I'm going to have 200. I'm going to have 300. I'm going to have 400. I'm going to have 500, 600, 700, 800. And my highest on X1 is what? My highest on X1 is what? Is 800. So I can stop at 800. And if you check this, I don't have from what? The negative part. Why? Because my what? My in my what? That is in my what? In linear programming problem. That is we do not have what? In stems, that is we don't have what? None, they are what? They are negative. That is they are not negative. That is our decision variable are non negative. Since they are non negative, so that's why we don't have from what? From what? We don't have from what? The negative side of x1 and x2, because they are not negative, and it's part of what? It's part of the stem, that is whenever we got our objective function and our constraint, we are going to have what? We are going to add non-negativity to the constraint, that is x1 s2 is greater than or equal to 0, that is add non-negativity to the add non-negativity constraint, that is s1 s2 is greater than 0. Since s1 and s2 is greater than 0 here, so it means I don't have for what? Negative what? I don't have for what? Negative side. So I can now locate my points. So when x1 is 0, my x2 is 600. I will go for my x1 is 0 and my x2 is what? 600. So it's on line. They are on a straight line. They are on a straight line. So I don't need to draw from it. When my what? S1 is 800. My x1 is 800. My what? S2 is 0. So it's also on a straight line. So I don't need to draw it. So I can now, but since my x1 is 800, so I will go for my x1 and x2 as well. So my x1 here is what? 800. My x2 here is what? 600. My x1 here is what? 500. My x2 here is 1000. And here is what? My x1 here is 500. And my x2 here is what? 96.7. So therefore, since if I set my x1 in second constraint as x1 is 0, my x2 is what? 1000, I'm going to get the same thing. So I will just plot x1 and x2, take x1 and x2, take x1 and x2, take x1 and x2. So I'm going to have, when my x1 is what? 800, my x2 is what? 600. So I'll go for my x1. When my x1 is what? 800, my x1 is 800, I'm going to mark the point. my S2 is what? 600. So I'm going to draw a line. So what give me x 600 and 800? So the constraint is what? 3x1. The constraint is 3x1 plus 4x2 is greater than or equal to what? 2400. So I will go for second constraint. When my s2 is what? When my s1 is 500, my s2 is what? 1000. My s1 is what? 500. I'm going to mark the point. Then I'm going to locate the point. My s2 is what? 1000. Locate the point here as well. So then I can now mark the point together by drawing a line. I will join the coordinate point together. So this gave me what? This gave me the second constraint, that is 2x1. 2x1 plus s2 is greater than or equal to 1000. So I'll go for my last constraint, that is when my x1 is 500. When my x1 is 500, here as well, my s2 is what? 96.67. Remember, in this O, this O is what? 10 units. That is, it have what? 10 units. That is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So if I add 100 plus 90, I'm going to get 1000. So one O here is what? 100. So 910, 920, 930, 940, 950, 960. So 970. So I can just take it here. It fall on here. That is, let me just locate the point here. Then mark it to what? When my what? X1 is 500, my x2 is what? 96.67. So this is 500 already. So I will mark the line together. So what give me this? So this give me this. I cannot say this under this. When my x1 is 500, so I can now write that is 5x1, the coordinate 3x2 is greater than or equal to 2900. So I've located the point on the graph. The next step is to find the feasible region. Remember that the next step is to find the feasible region. Feasible region is what? Is the set of possible points that satisfy the constraint. Is the set of all possible points that satisfy the constraint. So for me to get my feasible region of this is, remember, our objective function is to minimize. And I said in our steps in feasible, in drawing graphical method, that when our objective function is what? Is minimized, our origin, that is our origin, we are going to get the feasible region. That is, we are going to mark the feasible region far away from the origin. Suppose our objective function is maximize. Our feasible region will be from this point to here. It will not be far away from here. Since our objective function is what? Minimize. So our feasible region, to locate the feasible region, it will be far away from the origin point outside. So my feasible region will be from here. So this is my feasible region. So since I've located my feasible region, so remember that next is what? To locate what? To find the corner point of the feasible region. To find the corner point of feasible region. So for me to get the corner point of feasible region, for me to get the corner point of feasible region, for me to get the corner point is on the feasible region. Remember that this is our feasible region. So it is from where I mark as a feasible region. Where I mark as a feasible region will be my what? Will be my what? Will be my what? Will be where to get my what? Corner point. And our corner point is what? So here is one point. I've got another here from one point, that is here from here. Another point is what? I have another point here as well. I have another point here as well. And also here also. So let me start from what? So let me start from my work. So this, I can make this one. This is my first corner point. That is my A. I can let my corner point. Four corner point should be A, B, C, D. So it means this is my corner point. So when my S2 is 1000, when my S2 is what? 1000. So I will check for my X1. So when my S2 is 1000, what is my S1? My S1 is what? Is 0. So I can say my A is what? 1000. When my S1 is 0, as when my S1 is 0, I'm adding what? When my S1 is 0, I have what? S2 as what? 1000. So I will go for the second corner point. That is, my second corner point is what? If you look here, my corner, another point is what? Another point is from here. So another point is from here. This line should join together. So another point is from here, that is when my B is what? When my B is what? 710, 720, 730, 740. It's around from there. That's when my what? When my S2 is what? 740. What is what? What's my what? X1. So I'm going to have S1 as, so I'm going to have S1 as, so I'm just trying to, S1 is, that is when my what? S2 is what? 740. That is when my S2 is 740. That is my B. When my X1 is what? X1, I'm going to have what? 740. That is when my S2 is 740, I got my X1 as what? 150. This 0, 1, 2, 3, 4, 5. So another corner point again is here. Another corner point here is this. That is when my what? When my what? X1 is what? 400. When my S1 is 400, my what? S2 is what? 300. I can locate it from here. So this is the intercept, this is another intercept. This intercept, this is intercept. So when my what? S1 is what? S1 is what? When my S1 is 400, my S2 is what? 300. So this is my what? S1 is what? 400. So let me locate it. So this is my intercept. So my S1 is 300. Another one is 1, 2, 3, 4, 5, 6, 7. So that is 310, 320, 330, 340, 350, 360, 370. So I have 370. That is my C. When my S1 is what? 300. Yeah, my S2 is what? 370. So my D. So my D will be my D what? Last region. I can say this one should be my D. So my D, when my S1 is what? 800. Remember that when I start from the A, I take from what? From here, where my feasible region is located. From here. So my D will now be when my S1 is what? 800 and my S2 is what? 0. That is my S1 is 800, my S2 is 0. So these are the four corner points. So I'm going to use the first corner point. I'm going to what? Locate the point of the what? The coordinate point of the four corner point. I'm going to put it in the objective function. So the value, the point that gave me the minimum value will be my what? Optimal quantity. So at so therefore divisible region, A, B, C, D. So at A, what's my A? My coordinate point is 0, 100. So my objective function here is what? That is minimize Z is what? 120 x1 plus 160 x2. When S is what? 0. That when S1 is what? 0. My S2 is what? S2 is what? 100. So I'm going to put it. I'm going to have 120 0, 120 0, and what? Plus what? 160 100. So if I multiply this one by 0, I'm going to have 0. So I'm going to have 160,000. 160 times 100. I'm going to have 16,000. That is, I'm going to have what? 16,000 is 1,000. I'm going to have what? 160,000. 160,000. So at B, what is my B? My B is 150, 740. So what am I going to have? What am I going to have? I'm going to have 150 and 740. So I have to put it to the objective function. So I'm going to have 120 x1 plus 160 x2. So I have 120. What is my x1? My x1 is what? 150 plus 160. What is my s2? My s2 is what? 740. So if I multiply 120 by 150, I'm going to have 18,000. 18,000 plus. If I multiply 160 by 740, I'm going to have 1184. That is 160 times 740. So if I add it together, I'm going to have 18,000 plus 118,400. So I got 136,400. That is 136,400. So at C, so what is my C? So my C is what? My C, I got C as what? 300 and 370. So 120, 300, S1 is plus what? 160, 370. So if I multiply 120 times 300, 120 times 300, I have what? 36,000 plus 160 times 370. I have what? 59200. If I add it together, I'm going to have 95,200. So at D, so what is my D? What is my D? My D is what? 800 and 0. That is, my D is what? 800, 0. So if I put 120 into 800, then 160 into 0. So I'm going to have 120 times 800. I'm going to have 96,000 plus what? 0. So I have what? 96,000. So I have 96,000. So if you check it, so at A, I got 160,000 at A. At B, what did I have? At B, I have 136,400. At C, I have 95,200. At D, I have 96,000. So my minimum value here is what? 95,200. So my minimum value is what? 95,200. So the line D, at S is what? S1 is what? 800. At S1 is the line D. So my minimum value is C. The line C at S1 is what? 300. And S2 is what? S2 is what? 370. Gives me my optimal quantity. That is on what? That is on what? When I have what? When I have C as what? 95,200. That is my objective function is 95,200. So the optimal quantity is what? 95,200, which is what? Which fall on what? On C. So we have solved the solution. Okay.